Hi everyone and welcome back to Stephan Livera podcast. Today we're talking about Utreexo with Calvin Kim. Calvin, welcome back to the show.
Well, thanks. I'm glad to be here again.
So I checked the tapes. It's been over 2 years since that initial episode we did about Utreexo. Obviously, what spurred this now is you and I believe you and Taj and Davidson have put out these 3 BIPs relating to Utreexo. So I thought it would be a good time to get you back on the show, give us an update. So I guess just give us like a very, very quick, brief overview, and then we can sort of dive into further detail. What's the latest on Utreexo?
Okay. Yeah, so the latest on UTXO is that, we published the BIPs now. So the 3 BIPs are very specific to what they cover. So like in like SegWit or like Taproot, the BIPs are separated into like what they're for. Like there might be the P2P layer, and then there might be like the Schnorr signatures for Taproot. And so the 3 BIPs are one for the accumulator for the Utreexo. So this is the Merkle forest. These are the data structures and the algorithms themselves. And then the second is how do we now take that data structure and then validate Bitcoin blocks and transactions with it. And then the last BIP is the P2P one, which is, okay, how do we communicate these
Things
proofs
to each
for
other. Yeah.
to validate
Sorry.
the
Just what
nodes.
we
Yeah.
should do is probably just give a quick. So yeah, I mean, appreciate that, but let's start with a overview, or you know what? Let me try and summarize it in my simple terms for my fellow ADIQers in the audience, and then you tell me what I'm missing. Okay, so the basic idea is when we when we want to use Bitcoin, we can interact with Bitcoin using our own full node. The concept of Utreexo is kind of like a special full node that allows you to, let's say, quickly understand what is the UTXO set of Bitcoin, right? I guess it's like that's one way to sort of allow people to have a set and sort of understand, are my coins contained in this set?
Yes. So I guess if I was explaining it to my mom, I just say, hey, like you have a node, and you can make it small, but with what I'm doing, you can make it even smaller. So
Yeah.
that's like the easiest way that I would explain things. If some people that are more familiar with Bitcoin, I would like talk about Merkle trees, and so like Utreexo is just it's a different type of a Merkle tree. It uses the same Merkle tree concepts. And so, but this Merkle tree is specialized for the UTXO set. And so instead of right now, it's like a database, and it stores all the data. But instead of doing that, we just use Merkle trees to store a summary of the data. That's as easy
Yeah.
as I
Okay.
can as
Yeah.
I
And
can get.
I recall I was checking back our earlier episode as well. You were giving me this analogy of like a guest list at
Yep.
to get
Yep.
into a venue, and you're
Right.
saying the idea is how can you check that somebody is on that guest list but
Right.
in a
Yeah.
fast way, right? And that's
Right.
sort
Yeah.
of one idea or way of understanding this concept. And so the idea is this is like a special Merkle tree that allows not just additions but also deletions
Yes.
to understand, okay, this is what the UTXO set is. Like that is, quote unquote, the unspent coins. That is Bitcoin in a sense. So I guess normally the concept with Bitcoin is you're doing what's called IBD, initial block download. You're downloading the headers, and then you're downloading all the blocks. And
Yes.
then you are understanding, okay, do I have coins? Have I received coins? Do I need to send coins? This is, once, and then my blockchain, my Bitcoin node is staying up to date with the blockchain, right? To stay with what's called the chain tip.
Yep.
And then this Utreexo concept is so that you can, it's like a proposed alternative for the UTXO set that
Yes.
allows you to kind of very quickly download or very quickly participate in Bitcoin, is the premise, right?
Yes. Just like so, the very quickly part I should note is um is with this like trust assumptions, and so it's the same trust assumption as like assume valid. But it does have a trust assumption. If you wanted to like do your IB. So assume valid for people that are not aware is when you're first starting up your Bitcoin node actually doesn't check all of the signatures, and that is like assume valid. Like these blocks, you check the proof of work, you check the is this like transaction spending Bitcoin that actually exists? You check the amounts, but you don't check the signatures. And the assumption is that, hey, like these blocks are so old enough that we can like sort of skip them. And so that's like the default. And so if you don't want to have that assumption, then you do all the signature validation from the beginning. And
gotcha. And so the way people would do that, as an example in Bitcoin Core, is there's like bitcoin.conf, and I think it's assume valid equals 0 or something. Like you basically turn that flag off, and then your Bitcoin node is going to check everything from Genesis block, the first block, all the way. But by default, nowadays, most nodes just use assume valid because it's seen as like for somebody to go back and like somehow have those blocks wrong, but the current blocks would just be sort of quite a very high bar, right?
Yes. And so with like UTXO nodes, I guess the default could be that, hey, like it's the same trust assumption as assume valid, and so you start like near tip, and so you only have to download those blocks.
Gotcha. And so one other, I guess, just to explain the different types of nodes, right? So like I think you were, last time you were talking about this concept of a bridge node and a compact. A compact state node? What was the exact term?
Yeah, compact state node.
Compact state node, right? So the idea might be the bridge node is kind of like a seed or kind of like an Electrum server-ish person that's like a professional or somebody who, like, let's say a hobbyist or a power user who wants to run the bridge node to sort of help the network per se. And the compact state node, that's like our proverbial mums or grandmas who want to have an easy way to use Bitcoin without being like a super technical nerd, right?
Yes.
The compact state node is the one who's just sort of using these Utreexo proofs to understand, do I have coins or not? And being able to, participate in Bitcoin by doing some level of validation, but obviously not as much as if you had downloaded the blockchain yourself or obviously what the bridge nodes are doing.
Yes. So if you currently run a node right now, you probably wouldn't be that much interested in like a Utreexo compact state node. But the idea is we're not trying to replace like what people are running now. That's not the goal that we're trying to push right now. So what we are trying to do is, hey, like those people that are not running nodes because they don't have the means to, or they don't want to go through the hassle of doing that. Like, hey, like if you download a wallet, like it should already have a node on it. There shouldn't be an extra step of, hey, like you download, I don't know, like Nunchuck, and then you connect your node to it. How do you, what is a node? And you have to buy like an umbrella. Like for us, I think that's fine. We want to take control. And so that's fine. But for most people, we can't assume that for most people, especially as Bitcoin keeps getting adoption. So I think, so we're trying to push like these compact state nodes as, hey, like how do I get my mom to run a node? It's like, hey, like I don't even have to tell her that she's running a node. It's like, hey, download this app and you're fully validating blocks.
Gotcha. Yeah. So the idea would be not for, let's say, you or me or the listeners of this podcast, but let's say our friends and family who are trying to get into Bitcoin, and we've been trying to get them to like, use a hardware wallet and ideally connect it with their own node. And of course, it's kind of hard to get them to do that.
Right.
If we could have some kind of client app that also does some validation, that would be a strict improvement to today, where a lot of these users are, let's be honest, a lot of these users are custodial, right? Or these users are using some kind of client that relies on the server model.
Right. Yeah.
Where in this case, it's kind of like this would be a better client-server model, I guess we could argue. So the idea would be, hopefully, if this gets adoption, then there would be, let's say, wallet apps either on our phone or desktop apps that can use and be a compact state validating node that connects out to a Utreexo bridge who's kind of feeding them the proofs so that they can quickly participate in Bitcoin with a, let's say, a stronger guarantee or stronger assurances that they're not being, let's say, lied to or whatever.
Yes. One thing I do want to note there is that we did want to mention this in the BIPs as well, is that you don't have to connect to a bridge node specifically. You could connect to a normal archival node, and they would be able to, like normal archival UTXO node, and they would be able to provide you with all the data that a bridge node would be able to.
Gotcha.
So
okay.
did want to mention that because there was some confusion there.
Okay, gotcha. So you could be either a Utreexo archival node or a specific bridge node. Either of those can, let's say, serve the, is it the right term, the Utreexo proofs? Is that the term?
Yes, it's the proof message. Yes.
Okay, gotcha. Okay, so I guess the general idea here is, so Utreexo, I guess, is using this concept of an accumulator, which is, as I'm reading from your, I'm reading a quote here. An accumulator is a cryptographic data structure that allows for the compact representation of a set, enabling efficient membership proofs without requiring storage of the entire set. In the context of Utreexo, the accumulator tracks the current set of unspent transaction outputs, UTXOs. So maybe you just want to elaborate a little bit on this accumulator idea and just explain for the listeners.
So like the simplest sort of accumulator is a Merkle tree. Like the Bitcoin Merkle tree is an accumulator. It is a cryptographic accumulator. You don't have to store the entire set. Like for the Bitcoin header, it hashes all the transaction IDs into like the transaction commitments that goes in the header. And
gotcha.
so
this is in a block per se. So the idea is you can check, is this transaction part of that block?
Yes.
That's what we're checking in the standard Bitcoin case, and now UTXO is a more advanced case. Yes.
So UTXO, so we can use a Merkle tree to keep track of the UTXO set. It's just that it'd be very inefficient because a normal Merkle tree, whenever you want to recalculate the tree, you need to have the entire UTXO set.
Yeah.
With Utreexo, that requirement is not there. We don't have that requirements, and so there's that. So when I say like Utreexo is a special Merkle tree, I'm talking about like these sort of like features of Utreexo that allow it to be better suited to holding, like keeping track of the UTXO set.
I see. And as also in your BIP, just from reading the accumulator part, you mentioned this concept of a Merkle forest. So I presume that's what we're talking about. It's kind of like a special version of a Merkle tree. So I guess the standard Bitcoin thing that we're used to, or people might be used to, is the Merkle tree. And then this case is a Merkle forest. So can you just explain a little bit around that and elaborate on what is a Merkle forest?
So like what makes up a forest? Like a lot of trees, right? And so what makes up a Merkle forest? A lot of Merkle trees. So in the case of like the normal Bitcoin, like what it goes in the Bitcoin header is just one tree. With UTXO, it's actually a bunch of trees, and we keep track of all these trees, and we call that the Merkle forest. And this is what allows us to add new UTXOs without recalculating the or requiring the entire set to add something.
I see. So
add something new to it.
Yeah. So we can think of it like it's like the differences, right? We're just keeping track of the differences.
I guess we could go into details, but not even that. So like very basically is that like I don't know how to explain it.
Okay, gotcha. Let's come back to this then. So I see you've got operations here: addition, verification, and deletion in the accumulator. So, in the accumulator BIP or document. So maybe just talk, if you could just sort of talk through a little bit, what are those operations, and then we can understand from there.
So addition, deletion, and verification are the three consensus critical operations for the UTXO accumulator. So addition is, why do we need these? It's like additions because for Bitcoin blocks, we create new UTXOs. Deletions because we actually need to get rid of these UTXOs. Verification is because, hey, when we receive this new block, we need to make sure the referenced UTXOs actually exist. So those are the three operations, and that's the reason why they're there. So we have so we didn't talk about proving. So we talked about verification, but not proving, and we specifically left it out of there are methods in the BIP you can use to generate proofs, but we specifically left it out in that BIP because it's not critical to consensus.
Okay.
Like you can generate a wrong proof, but it's like the worst case is that people just reject your proof. It's not consensus critical.
Yeah. Okay.
So,
and I guess we should just clarify, just for listeners who aren't sure here, this is not like a soft fork to Bitcoin. This is like what we're talking about here is just like an optional side piece of software that you can run or not run and still use Bitcoin.
I do strongly want to mention that if you don't care about Utreexo, you could completely ignore this and you'd be fine. There's going to be nothing affecting you. We're not trying to force onto people anything like new. Like I personally wouldn't want that, and so this is not what we want to push. And so and we worked very hard. There was extra work gone into making this be like an opt-in feature. So I want to make that very clear.
Okay, yeah. And then so we've got there's a validation, Utreexo validation BIP. And so here from the abstract, this BIP defines the rules for validating blocks and transactions using the Utreexo accumulator. Okay, and so I guess what you're saying is basically the idea is that the Utreexo nodes can stay in consensus with one another. So do you want to just elaborate a bit on that and what it means?
Right. And so so we have the accumulator, but we don't know like how to use this accumulator. Like, hey, like what goes into this accumulator? Like what doesn't go into this accumulator? And what we add to the accumulator are the UTXOs themselves, but like what consists of that UTXO data, and like how do we serialize that UTXO data? Because if we serialize things in the wrong order, then like you wouldn't be able to communicate with other Utreexo nodes. So those are the things that are defined in the validation bit, like anything that has to do with Bitcoin specific things. So like with the accumulator stuff, there's actually nothing Bitcoin specific there. Like you could completely treat it as its own thing, and you could like other researchers could actually like take that and use it somewhere else. But with this, it's like very Bitcoin specific. We take what we built up in the accumulator BIP and apply it to Bitcoin so that we could verify blocks and transactions.
Gotcha. Okay. Okay, so that's the part of staying in consensus with other Utreexo nodes. And then also you have a P2P BIP also. So this is the Utreexo peer-to-peer BIP. And, and as you were saying and discussing earlier, this is how the Utreexo nodes can talk to each other. So can you just elaborate a little bit on what that looks like and what the differences are there with a Utreexo peer-to-peer node versus just standard Bitcoin?
Right. So we introduce like new messages. So for like blocks, you need a proof with those blocks. And so how do we communicate those proofs? For the transactions as well, how do we communicate like proofs for the transactions? So we introduced new message types to Bitcoin. And so these nodes, the current nodes can just opt to just completely ignore these messages if they want. They don't need to respond to these messages, nor do they need to even know about these messages. But the Utreexo nodes, or nodes that really want to communicate with Utreexo nodes, so it specifies like this is how we communicate. So these are the data types. This is how we serialize those data, and this is how what the message flow is like between two nodes. So anything that has to do with communication with other nodes wanting to exchange proof data is defined in this bit here.
The lead sponsor of this show is Bold, the banking platform designed for Bitcoiners. With the Bold virtual Visa debit card, you earn Bitcoin back on every purchase. The more Bitcoin you buy with Bold, the more sats back you get on the card. Buy $2,500 of Bitcoin and earn 3% sats back. Keep stacking with Bold to earn up to 10% sats back. Bold offers the industry's lowest fees on Bitcoin buys and sells with zero added spreads. When starting out, you can use Bold Wallet, which is managed by the team, but Bold is also supporting self-custody with Bold Vault, a 2 of 3 collaborative custody multisig for zero monthly fees. With Bold, you get your own FDIC-insured checking account to store and send fiat, pay bills, direct deposit your paycheck, and replace your legacy fiat bank. Sign up today and get 0 fees on your first $10,000 of Bitcoin buys and $25 of free Bitcoin when you buy $100 of Bitcoin or more. Go to getbold.io. This episode is brought to you by CoinKite, the makers of my favorite Bitcoin hardware wallet, the Cold Card Q. Now, some people think self-custody is too hard, but it's really about taking responsibility for your Bitcoin wealth and understanding that self-custody gives you a true feeling of liberty. The Cold Card Q has a full keyboard and big screen. It's got 2 secure elements and a true air gap, allowing you to go fully air-gapped using QR codes from seed generation to transaction signing. You can power the device using 3 AAA batteries, so you don't even have to plug it into the wall for power. You can easily use it with Sparrow Wallet for PC or Nunchuck on mobile, and you can dial it into the right level of security and complexity that you choose. If you want a simple setup, just use 12 words and single signature. If you want passphrases, easy. If you want to add multi-sig or co-signing features, you've got those too. So go to coinkite.com, use code Livera to get 10% off on your cold card or other devices and level up your self-custody today. Gotcha. Okay. Yeah, and of course, links will be in the show notes, but I think an interesting one is there's a diagram. Maybe we can flash it up here, but basically it's showing the serving node and the IBDing node, or initial block downloading node, and then you've got just kind of a listing of the messages there. So it's get headers, get data, block, and then get Utreexo proof, and then block and Utreexo proof. So I guess obviously the new things there are get Utreexo proof, and the serving node is the one who's also serving the Utreexo proof. So is that kind of a fair summary? These are some of the new things that are being brought in, but it's only relevant for Utreexo nodes, not for just vanilla Bitcoin Core or Bitcoin nodes.
Want to again mention, if you want to completely ignore Utreexo, you're very there's nothing you have to do. There's no action you have to take to ignore these new messages.
Of course. This is like totally an opt-in thing, and the idea would be that the proverbial grandma can just download an app, and that app can quickly be a validating client. So last time we spoke, it was sort of the idea is that this proof could only be, or is it the proof or the set is only a few kilobytes? Can you just elaborate? Is that still the case, or what's the latest there?
Yeah, the set is still a few kilobytes. It's usually less than a kilobyte. But so the current UTXO set, I think it's about 10 gigabytes now, and there's no cap on this UTXO set, and so it keeps growing. And so we have so with Utreexo nodes, this UTXO set just remains about a kilobyte, and
so this makes it very easy for the proverbial grandma to just have it in her app or whatever, and then it requires more storage on the bridge node or on the full Utreexo archival node because they're storing because they have to also create proofs. But this is kind of, again, this is like a role for the, let's say, power user, hobbyist, professional kind of person, not the grandma. The grandma is going to be on the compact state validating node, and the bridge node is going to be like a professional or someone who really knows what they're doing. So can you just explain a bit about the bridge node, what's required there, storage and computation costs for that bridge node?
Yeah, so the bridge node, we call it a bridge node because it bridges the current Bitcoin nodes and Utreexo nodes. So what the bridge is only responsible for creating proofs for newly broadcasted blocks and newly broadcasted transactions. And so one thing that I want to mention is that you can be a pruned node and still be a bridge node, because a bridge node's responsibility is two things, create new proofs for new blocks and new transactions. So what archival nodes then do is they store the block and the proof together. And so different node types could be, you can be an archival Utreexo node and not create proofs for new blocks and transactions. Or you can be a pruned bridge node, and you don't serve the historical blocks, but you create proofs for new blocks and transactions. You can be both. You can be a bridge node and an archival node, but that's not a requirement.
That's not the only case. But I guess it's probably fair to say, would you say most of the, let's say, hobbyists or kind of people who are trying to quote unquote help this network grow, they would just do both, right? In practice.
If you have a node, then you would probably just do both, because it's why not?
Gotcha. Yeah. And so I think you might have told me this last time, but it's basically like storing almost like 2x the current blockchain size to be that bridge node. But again, we're talking about the professionals and hobbyists and power users here. So for them, it's not a big deal. But we're talking about basically that in that range.
The historical proof size is slightly less than the entire historical block size. So about 2x.
Gotcha. Okay. And so also, how do these Utreexo nodes find each other, right? Whether that's Utreexo nodes, bridge nodes, or compact state nodes.
Yeah. So you don't differentiate between like the bridge nodes and archival nodes, but you do differentiate between like these compact state nodes and bridges and archival nodes. So currently in the Bitcoin network, if you want to signal to other nodes that, hey, like I'm an archival node, then there's a message flag that you send to your peers. You're saying, hey, like this is the supported, like the features that I support. And you say like node network for archival nodes. And then you do like node network limited if you're a prune node, and you can only serve blocks from the last 2 days. And for UTXO nodes, you would also like advertise that, hey, like I'm a node UTXO, to say that, hey, like I understand the Utreexo protocol, and then I also am able to broadcast, like receive and broadcast like blocks and transactions with the Utreexo proofs. And then you have the node Utreexo archive, which is you are able to serve historical proofs, not blocks, but only historical proofs. So you can, so like you, if you want to do this, you are able to just store the historical Utreexo proofs. And so what the IDing node would be doing is that you would get the blocks from a like a current archival node, and then you get the proof from a Utreexo archive node.
Gotcha. Okay.
So it's very modular, but yeah, as you mentioned, like most people, they would just do everything. So they would store all the historical blocks, all the historical proofs, and then be a bridge node as well, where you create create proofs for new blocks and transactions. But like they're very modular. You can.
And for now, are there bridge nodes operating? I presume you're operating one, and is it Davidson and maybe a couple other hobbyists? And the idea is that you guys are kind of helping bootstrap this, but maybe in the future, do you envision that actually services or wallet providers might actually operate some more bridge nodes themselves, or who's going to do this bridge node role?
Right. So yeah, at the moment it's just me and Davidson, and as we get things rolling, we hope to have more adoption. And so the implementation side is still being worked on, and so we're coordinating like how to get more bridge nodes up for that. But in the future, I sort of envision like maybe it's not a good comparison, but I sort of see the comparison as like the Phoenix wallet, like the Lightning wallet, where hey, like you don't like not every Lightning node needs to be like the service node. Like you don't have to like transmit payments, but you could just like be connected to one of them, and you can transact funds that way. But you're not like it's just the app that you run on your phone. So I can sort of see in the future, hey, like if I download a wallet app, then I just connect directly to their bridge node, and then they will be like giving me proofs for blocks and transactions.
Yeah,
and
gotcha.
The assumption, so the assumption here is that you're trusting them for the data being provided, but you're not like entirely trusting them. You're still validating that data that they give you. Like so
Correct.
They could admit the data, but they can't lie to you.
They can't lie to you and trick you into believing you received a transaction that you did not receive. And that's the important point here. And I guess I'm sort of thinking it's kind of analogous to, in the old days or even today, there are certain public Electrum servers, right? So as an example, there might be Electrum client users, right? And if you think back to even the OG kind of Electrum wallet in 2011 and the way Thomas spoke about it, the idea was there were a lot of custodial users, and he wanted people to be able to just run this Electrum client without having to like run the full thing. So there were and are people who just run public Electrum servers, and they're just kind of publicly available. So I guess this is kind of a parallel that maybe in the future there might be people who use these easy compact state node wallets or apps, and then there are just public Utreexo bridge nodes and Utreexo archival nodes who just kind of serve up the proofs because they just want to help the network kind of thing and help these people be able to use Bitcoin easily.
Yeah, and I also want to mention that Thomas Fee was actually super interested in Utreexo because like he wants to make the Electrum wallets like more like trustless as possible, and
Gotcha.
Utreexo would
So maybe this would be
yeah.
something he would be interested to support in Electrum wallet.
Yes.
Interesting. Okay. And while we're here, of course, I know there is a project, Floresta, which I believe uses this, and I believe this is Davidson's project, or is he involved with it? Maybe you can just give us a quick overview, just because I think this might be actually useful for people to understand a practical application here of Utreexo. So give us a quick overview of Floresta.
Yeah. So Floresta is a full node implementation that doesn't keep a UTXO set, like doesn't keep the entire UTXO set, but uses Utreexo to keep to be in sync with other nodes. And so this is a implementation of the compact state node that we talked about, and Floresta has bindings to other languages so that developers can just take it and then put it in their existing wallets or services. And so this is a project that makes it possible and allows some bootstrapability for existing wallets and other maybe companies that are interested.
Yeah, and I think it's also really interesting because instead of users being I guess it allows, like we were saying, comes back to that same idea that it's like a real world example of that compact state node, and it gives people a stronger assurance that they really do hold coins instead of having to trust being in a sort of let's say a more trusting client server model. This is like a validating client model, let's say.
Yes.
And so UTXO D, as I've seen in the documents and stuff, UTXO D is, I guess, the implementation, the code of this. So can you explain a bit about Utreexo D, what it is?
Okay.
Yeah.
So Utreexo D is everything that's in the BIPs. It's everything Utreexo related. So
it's like the practical implementation of what you spoke about in the BIPs.
Yes.
Let's say.
So so it's like, hey, it has accumulator, it has the bridge node, it has the archival node that doesn't have the bridge capability. It also has the compact state node capability. So it's basically I would say it's a reference implementation of everything related to Utreexo. Floresta is a more very specific version of that, where it's just the compact state node, and it has a lot of features that Utreexo doesn't have, like these bindings to other languages. It also supports this soft chains SPV thing that uses Utreexo as well. And so there's a lot of features, but all those features are geared towards, hey, let's make this the node for grandmas.
Gotcha. Yeah. Okay. And so we can think of it like this: a lot of the Utreexo archival nodes and Utreexo bridge nodes, they may run Utreexo D, whereas the proverbial grandmas may be running Floresta or something like that, a compact state node. That's kind of what it is. And then, as I'm understanding, these three BIPs that you're proposing, they are kind of like if someone wanted to implement their own version of Utreexo D or some competitor to Utreexo D, they would need these BIPs to sort of understand the method by which Utreexo is being done. Is that the right understanding? Yeah.
Yes.
Gotcha.
So with all the information provided in these BIPs, you would be able to create a client that is able to communicate and keep up with the Utreexo D nodes and the Floresta nodes.
Gotcha. And the idea is, how would you stay in consensus together with them? Yep. And so this would be, maybe technical minutia for the everyday user. They don't need to know about this, but this would be for the developers and builders who maybe they've heard an idea here and they want to build something here because maybe they think, hey, I want to build a compact state node wallet or app or something like this, or I want to use Floresta as part of my thing. So what are you looking for from here? Are you looking for review, builders to kind of build on this, or developers to help contribute? What are you looking for?
For the moment, we're just hey, this is what we came up with. We talked about Utreexo for years now, but we worked very hard on the specs, and the specs are actually like we sort of went went the extra mile where it actually supports a lot of like caching, and that was sort of tricky to figure out. And so like we want like reviews from builders that are interested in Utreexo and sort of take a look at this and say, hey, like this is sort of cool, or hey, like why don't we do this? So I guess we're looking for ideas with the BIPs.
Gotcha. Yeah. Now, also, just to touch on this whole idea of different Bitcoin implementations, as I'm understanding from you, UTXO D is based on BTCD, which
Yes.
is another implementation of Bitcoin. So, as listeners may be aware, there's Bitcoin Core, obviously the dominant implementation on the network today. There are other implementations. So, can you just discuss a little bit about, BTCD and building on that?
Yeah, so BTCD is an implementation of the Bitcoin's of Bitcoin in a language called Go, and right now it's a node as well, but it's also a library as well. So a lot of developers that implement wallets, or like especially something like the Lightning nodes or like LND, it relies heavily on using the BTCD libraries to like basically to stay in consensus, like because they don't want to be implementing all these basic Bitcoin messages. So
Yeah.
that's what BTCD is, and it's mostly at the moment a lot of people from Lightning Labs work on it.
Yeah.
So we have BTCD, and then originally the Utreexo implementation was in Go, the same language, and it's hard to work in between languages, so it was the natural choice to
Yeah.
fork BTCD and then to put Utreexo in. And so yeah, that's the relationship with like Utreexo D and BTCD. I should also mention that like the Utreexo D codebase and BTCD codebase is very, very similar. There's only a few differences, and so I contribute nowadays like heavily to BTCD as well.
Gotcha. Yeah. Okay, so I think those are the key questions that I had. So obviously we'll put all the links there in the show notes for people to check out the BIPs and give their feedback. I guess while I've got you also, any updates for people in terms of Bitcoin community in Seoul and Bitcoin community in Korea? What's
Ah,
happening these days?
Nowadays, lots and lots of activity. So yeah, there's beginning of this year, we've created an organization called the Bitcoin Social Layer in Korea, and it sort of allows people that are like doing individual work, like we're all sort of separated, but then um, it's it's hard to get things moving forward in Korea. It's very there's a culture of doing things together, and this organization helps us do that. And so we're there's a lot of activity on like meetups. Meetups are hosted by BSL as well. Translations, a lot of translations for books, videos, games as well. Like there's a game that helps you develop, like get introduced to concepts called like Saving Satoshi. That has now been translated to Korean as well. So and then besides that, we also have like there's a mining sect, like a mining guild in BSL as well, where they're teaching people how to mine with like bit axes, and if they want to do like commercial mining, this is where people are like doing things together to like sharing knowledge and then figuring out like how do we profitably mine in Korea. Other things are there's a payments guild where they're trying to get like or basically orange pill local shops in Korea. So now there's over 100 shops in Korea accepting Bitcoin and Lightning payments directly. So there's actually a separate website like btcmap.kr where there's a map of like the shops where they accept Bitcoin in Korea. So there's a lot of activity going around with BSL, and lots of, well, way more than when we originally talked about Utreexo 2 years ago. So I'm very happy with that. And yeah, we're also, so with the help of BSL, we're also hosting a conference later this year. That's very like entirely community based. So like lots of things going on now.
Yeah, well, it's great to hear all the updates and how things are evolving there. Maybe you can push some of those Korean merchants to be a compact state nodes and see how things go there. Of course, I mean, that would be if they're taking on-chain payment. Obviously, Lightning and Arc and Liquid and whatever else is different. Yeah, so we'll put all the links in the show notes for listeners to stay up to date there. And yeah, thanks for sharing with us today.
Yeah, thanks for having me.